Windows person friendly. Okay.
Yeah.
Sometimes I regret I didn't study medicine or something. Welcome to another episode of AzureTalks. Today I'm accompanied by Robin Smorenburg, our new co-host for this show on AzureTalks. I'm very pleased to announce him as someone that will help me within hosting AzureTalks, and I will continue this journey with him. So welcome, Robin.
Thank you.
Robin,
happy to be here.
Yeah, so you're an Azure MVP, you're a lead architect at NorCloud, you're a LinkedIn learning instructor, and enthusiast about Azure. Is there anything that you want to add to that in our audience, or are there some things that we can expect from you in the near future?
Oof, good one. I'm working on quite some things. We recently shut down streaming clouds, unfortunately, right? But I'll be live streaming individually or with some other people under my own name. So yeah, stay tuned for that.
Awesome. And today we have also a very special guest, senior cloud advocate at Microsoft, a former Microsoft MVP, if I had done my research correctly, Pluralsight author, book writer. You're also creating a lot of YouTube videos. And might I add to that, cloud native evangelist, Josh Duffney. Welcome.
Thank you very much for having me.
Awesome. And I'm very eager to learn a lot about securing supply chains on AKS from you today. So that will actually be the topic that we're discussing here today. Let's just dive right in, right? So my first question, what are key challenges for securing a containerized supply chain?
There's several aspects. So one of them is what you'll hear is provenance. Like, how do I trust where this container images come from? Well, I guess to take a step back, really where a lot of this stuff kicked off was a couple of years ago. Well, probably, 5 years ago, 6 years ago now, with the SolarWinds, the Log4j exploit, right? Where they hacked the secure supply chain and they embedded stuff into their software that they didn't know was there. And so that's where it became important. And there's a couple executive orders, one from the Biden administration fairly recently, that are putting some more pressure on companies to adopt more, or to come up with, as an industry, these standards for ensuring that our supply chains are secure. So there's a couple elements we're going to use in the context of this conversation: containers. So if you have other means of deploying your software, a lot of the tooling and stuff is really, that I'm about to talk to, is really focused on containers. So in that context, the number one thing is how can I trust this source? How can I trust this particular container image? And that's where that term provenance comes from. What's the origin of this particular software? And the answer to that is to use, like what we do with many other things, signatures, digital signatures, these hashes. And if you dive into kind of the innards of containers and how they work, you'll notice all these, these usually it's SHA-256 generated hashes that are used to uniquely identify layers of a container image. But that same mechanism can also be used to verify the signatures, right? And so there's an open source tool that we'll talk about in this time here that I have with you called Notation. It's one of many tools. So since it's in a new and evolving space, there isn't really consensus on, who's the very best or who's the industry standard. There's more common ones, and typically different cloud providers kind of adopted one particular open source tool. But I'll be talking about Notation, and that does signatures. But that only ensures that, what I expect to have here, or I can trust this particular thing, is validated. And that's on the left side, where you create the container image and then you sign it. Oh, hey, this is something I built. Here's a signature that proves it. But then there's other aspects to it, like the base image. There's so much that goes into creating a secure container image. Some people have gone with distros, where they kind of remove everything. A very common pattern that I've seen is from scratch, where you just leave your binary on the file system for your container, and you don't take any of the other file system with you. So if you're using a Ubuntu file system for your build, and then you produce the binary, and your binary doesn't need any file system objects or file system objects, files, or folders, you can literally blow everything away with from scratch in a Docker container if you're using that to build your images, and just have your binary, and that could be secure. But that also injects other things down the pipeline where, what if I want to patch this? There's nothing there to patch, and my scanner is going to be all out of whack because it's going to be pulling from my base layer. So that's another aspect, is how do we secure base images? And then another area would be, okay, well, I put all these things in place, but I don't have any teeth. Like I can't prevent anybody from deploying an unsigned container image from my cluster. And that's where another tool that I've worked with, I was hacking on this morning to solve some issues, which is Ratify, and that's an admission controller. So if you look at deploying to an AKS cluster, so containers, there's many other ways to deploy, but for the context of this conversation, we'll be focused on Kubernetes, and more particularly AKS because it's Azure. But the admission controller can actually look and use different verifiers to say, hey, does this image that you're about to deploy into this pod have a signature? And if it doesn't, then I'm not going to let you deploy. And so that's where the teeth come in, right on the right side of that pipeline. Like, how do we actually prevent this and add some governance and policy around our environments to ensure that these things that we're doing, these checkboxes that we're having kind of written off when we create our images, are actually having some effect in our environments. And then I guess the other one, kind of to wrap it up, would be patching. Like patching, people kind of get look at you sideways when you talk about patching containers. Like, well, why wouldn't you just rebuild it and update the base image, or update, do the updates inside the container build? Well, there's going to be situations where you're dependent on an upstream container, and if you upgrade to the next version that has some patches, if it exists, could break everything in your application, and maybe you don't have the dev cycles to account for that. And so then there comes the need to patch those container images. And those people of us who operate and run Kubernetes clusters know that those updates, like, you have to keep up with them, or it's going to be a struggle. And so there's a lot of work being done in the industry to kind of address all those questions. So that's a long-winded answer, but those are all the things that have been kind of on my plate that I've been exploring for the past, I don't know, probably a year and a half since I moved into the cloud native team here at Microsoft.
Awesome. Thank you for that answer. And your answer is like ominous. I had a whole lot of questions written down for this conversation, and you already answered a lot of them.
It's a wrap. 10 minutes in. We're good.
It's a wrap. Thank you, and see you next time. No, but one thing that keeps popping in my mind, and when I'm working with customers as well, within it could be containerization, it could even be infrastructure. So open source. How trustworthy are open source tooling? How trustworthy? Because you're talking about trust. What dependencies are we creating when we use open source tooling like that? What's your view on that?
Well, I think open source has kind of proven it, like, it's with the backing of all the big tech companies and the copyright, it's just the best way to develop software and to have it out in the open. And there's a big boost in transparency and learning that can be shared across. So I don't think open source is going to go anywhere. If anything, it'll probably increase. I think the model is changing for how it operates, because we're also seeing, with the difference in the economy, a different business model that needs to kind of evolve with the open source to maintain it. There's not this kind of like endless VC funding money where devs can just spend a bunch of time contributing to open source. There actually has to be some kind of business mechanism behind it. And we're kind of seeing that pressure now. But it becomes, what's interesting though, is in the emergence of securing open source is at the forefront again with creating the tools to do exactly that. And so I think adopting the supply chain practices and the tools that come along with that are how we both can secure open source and internal stuff. So the same tools for both internal and external. So I think, just maturing our security practices around how we build and deploy software is kind of the answer in both scenarios.
It's actually funny because there are a lot of trust issues towards open source tooling and open source software. But what you're actually saying is that they are at the forefront of security and securing your workloads and your applications. So it's funny that it's actually some anxiety for something that's not there. That's actually what I
That's a
get
good way to sum
from
it up.
from your answer.
I would even go a step further that open source is maybe even safer because the source is open, right? So you can actually see what's going on in the software before it gets compiled, right? Before you get a binary out of it. So yeah, I
Yeah,
think
and it's all tracked. It's usually on GitHub, right? So you can go through the commits and see the different hashes and stuff. But yeah, one important element that I dove into last week that I didn't mention in this supply chain is the SBOM. So you can't look up secure supply chain without SBOM. To be perfectly honest, a lot of it's still in the works and there isn't a lot to it. But in general, what an SBOM is supposed to do, what it was provided or invented for, was to give you that full transparency all the way down to the language from your application. So there's a lot of tools out there. I don't think it's quite yet ready for adoption, in my personal opinion, just because I haven't seen a ton of utility in it. Like once it's generated, and like how do we increase visibility? Some of the intent behind it, though, is to be able to use this artifact, the SBOM, which is a software bill of material, very much like you look at the back of your milk carton. Here's what's in there. Here's where it came from. Was the cow grass fed or whatever it is that you're looking for? The aim of it is to provide that level of transparency with software, and software from like what are the dependencies from the language. Maybe it was written in Go and I'm using my Go mod file and parsing that and adding that into the SBOM to say, here's all the packages that I consumed in my tool that consumed other packages. But then also there's SBOM generators for your container image. So what are all the layers inside this container image and what are all the software that it's using? And then those combined can give you an idea of the kind of the full stack. Right now, really, it's at just the generation part. A lot of people don't do a ton with them. It's more of a kind of a checkbox to do if you're working maybe with some federal governments. But I think it's a space to watch that will add a lot of that transparency, because the promise is you could look at your SBOM reports and use point vulnerability scanners at it and see which applications in your environment are exposed to a particular CVE. That's the promise. The tooling isn't there quite yet, but that's at least an area or a technology to be looking at. But yeah, that would greatly increase the transparency, because yeah, it's on open source, but really, who's got the time to go and pour through the thousands of lines of code to see what dependency was pulled in where? And then the build process is a completely different thing. You could have an open source project that doesn't have its build exposed. It might be building on a different platform. It might not be using GitHub Actions, and so you can't see exactly what's being done when the image or whenever it's compiled, whether it's a containerized app or not.
It's the SBOM. I had to look it up. It's the first time I hear it. Pretty interesting stuff. But is that one signed as well?
Yes. Well, okay. Ideally, right? You would want to have some kind of verification that the SBOM itself hasn't been tinkered or tampered with. And so the provenance and signature kind of goes to all artifacts. So I've been doing a deep dive into the OCI spec. So that's the Open Container Initiative. And that defines all the manifests that are attached when you push something to a registry. And was originally created to be able to have a standard format to create a container image, right? So whether Docker built it or some other tool, and then whatever runtime, if you're using Docker to run it, the daemon to run it, or if you're using containerd on Kubernetes, that format allows it to transfer between all those different tools and the different runtimes. But it's been extended. You'll see all these things that I'm talking about here are appending or attaching to the referrers of a particular image. So a signature will have a refer inside the image to the signature, and then that signature is then used to verify. So there's something in there. There's a refers API in the OCR artifacts, and that is basically just a Merkle tree, which I don't fully understand quite yet. But it gives you a tree, data structure of a tree to be able to traverse and find out all the referred objects in the container registry for a particular image, whether it be a signature, an SBOM, or whatever. And so a lot of people are using registries themselves to house all these artifacts, the signatures, the SBOMs, and so forth.
So when looking through the guides and through the more of the adoption and reference, the architectural reference frameworks that, Microsoft provides, we have like the cloud adoption framework, well-architected framework. We have things called the Zero Trust framework. I can imagine that when I'm an organization and I want to start with rationalizing my applications and I want to do something with containers and maybe even with DevOps practices, so pushing it in CI/CD pipelines and want to secure my full supply chain. What is the starting point? Where do I begin?
So what I've seen is people usually begin with signatures. I don't have the exact name of it, but there is some work being done by a gentleman at Microsoft to address kind of like the high level policy. So what architects would probably use, or kind of the senior leadership would use as kind of a North Star or a blueprint framework would probably be the best word for that. I think it is called a framework, but he's been working on, and that's the higher level. More what I've been doing is the implementation. But the gentleman's name is Adrian. I forget his last name, but I will make sure that I find that and send it so you can put in the links for people that are more concerned at the higher level.
Awesome. Good question. So, so let's dive a little bit deeper within actually securing your supply chain and your practices with using the tools that you just mentioned. When looking at securing your supply chain on the implementation side, take us with you. How does the process start, and
Sure.
where do we begin?
So I did a talk at Build what was it, May? Oh, it's been a while now. But anyway, I created this repository and I've been hacking on it since, so it's still up to date. But go ahead and throw my screen up on there so everybody can see that. And I'll walk through this repository. And then I'll walk through some of the workflows inside of here. How's the font? Is that pretty good?
Yeah,
Good,
perfect.
really?
Perfect.
Awesome.
Yep.
So this is an example repository that you could use. You could clone this or whatever you want to do, fork it, that you could use to modify. So in here, we'll just walk through the code real quick. There is, if you're familiar with the Azure voting app, so essentially that's a page. It's got two options.
Cats and dogs, right?
Cats and dogs typically,
Yeah,
but
yeah.
there's a running, I'm increasingly becoming outnumbered. A divide on my team between Rust and Go, the programming languages. And so we modified it to be Rust and Go. But yeah, it's the dogs and cats example. But anyway, that's underneath the source and the static and stuff. But my coworker rewrote it, and his name is Paul Yu. Does a lot of amazing stuff with AKS. If you're familiar with that, definitely try to find him on the internet, the interwebs. But he rewrote it in Rust. Essentially what it is there's a front end of the web application, and then it uses a Postgres database, and it's just a simple 2-container deployment that I push to Kubernetes. I've been meaning to refactor this to use my URL shortener. Just nice little coding project that I did on the side, but I just haven't done it yet. Been lazy. I need to push. But that's the application that this is going to do. But if you look at, let's just take a look at this image here. We'll bring it up full screen. This is the very, very high level of what I'm talking about. If you wanted to start to implement some of these tools and practices in your workflows. So this will all be in GitHub Action workflows, but it works equally well. All these tools are available as CLI tools. Most of them have whatever the term would be, if it's a plugin or if it's an action. GitHub calls them actions, where they're wrapping the CLI. But even if they don't have it, they're all command line interfaces that are really easy to kind of inject and add into your pipelines. But it all starts with scanning. So kind of shifting as much as we can left, if we can avoid it, why would we want to inject or start containers that already have known vulnerabilities? Why wouldn't we want them to be as patched as possible, even if they were built with the latest and greatest tag right from their base image, so to speak? And so the beginning of this process will start with Trivy. So Trivy is a vulnerability scanner. And one of the options that it has is to output scanning results. And so that uses the CVE, or the vulnerability database, and then it creates a nice report. The next tool, which has gotten a lot of traction, which is super, super cool, is called Copacetic, Copa for short. That's what the command line is. And what it's able to do, right now it only works with Trivy, but it will be extended to other scanners probably in the near future, is it takes that scanner results and then opens up your container and starts to patch. Right now it does the OS vulnerabilities. They're working on the application, I believe. So if there are any OS level vulnerabilities, say you're not using a distroless container or something like that, maybe you're just using Alpine or you're using Ubuntu and you're using that full file system, there's a bigger attack surface there because there's a lot of different things on there, even if your app's not using it. And so what Copacetic is able to do is to open up your container image, patch everything it can based on the scan results, and then it creates you a new image. And so what you can do is build your image, scan it, patch it, and then have a new version of that. Now comes the point of how do I trust that this is my image and it's exactly the same thing that I'm expecting? And that's where Notary comes in, our notation. Notation is the CLI. And what that allows you to do, and this is kind of an important lesson that I learned going back to the digest. So the digest is that long alphanumeric string that uniquely identifies a particular layer. And so you want to use notation to sign the digest because it's immutable. If you use a tag, it's immutable. You could overwrite tags and then you've lost your trust, right? So you can sign the digest once it's gone through all this build process, right, in the workflow. And then you can eventually push it up to your container registry. Once it's in the registry, though, we need to have some kind of mechanism that can check that it was signed. So in this particular example, I'm not using any other verifiers. Verifiers being different attached artifacts to the image that I want to ensure are there. In this one, I'm only using signatures. So notation will attach an artifact inside the registry to the image via the refers API. That's one mechanism it's discovered. And it will say, hey, here's the signature and here's the actual hash of the signature. And then Ratify is another tool that is in combination with Open Policy Agent or Gatekeeper, if you're familiar. And so those work together to kind of create a policy and verify around it. And the end result, really, to sum it up, is, can't really see it with my dark mode on, but it is, you can see the point of green and red, though. Green means go, red means stop. But if you don't have the signature, you're not going to get deployed to a cluster, essentially what that is. And this is all scoped by namespace. So you could have development namespace that you don't really care, let the developers go and deploy whatever they want. But when you get to production, we're going to require that you have a signature. And so that's how the deploy phase kind of works. So I've gone through the high level, but I want to give you kind of the nitty gritty, like what this works with. Before I dive into the workflow, though, and get too far into it, all of this is part of a workshop that I've done. So if you go into the docs and do workshop, this will kind of guide you through, literally everything. I walk through installing the different tools, setting up the dev container where I've automated installing all these, so you don't have to go to all these repos and curl them down and move them to your bin directory. All that's been taken care of in this workshop. But this will walk you through, literally step by step of everything that's in here if you want to go deeper and deeper into the things that I'm talking about here. But yeah, just a quick call out that it is a workshop that you can go in and work on. Even as far as setting up your GitHub Actions. So if you go into bonus, this is where all the automation and commands. Big fan of command line and scripting. My previous world was all PowerShell, so it's been a bit of a change going to all bash commands. I feel very silly at times where I could solve this so easily in PowerShell, but all this is in bash. But needless to say, if you want to dive deeper after this kind of brief explanation and go deep into these things, inside the docs folder is where you want to go. But if we look at the workflow, and I'll talk about another scenario for Copacetic in a moment. But here is, just make this a little bit bigger. Here's what the workflow looks like, because it's nice to see the flow chart because you get this big overview, but then I want to make sure that there's a connect for you when it comes time to actually building out your pipelines. And so in here, and some of this can be improved. Typically, you'd want to have some kind of variable, or maybe you want to use the GitHub SHA to generate your tags. But I'm just statically kind of creating this one tag. Maybe after the run, I should update this variable or something, but it serves the point. You kind of understand. But what this build does is it checks out the code repository, because we're keep clicking on things. Sorry about that. We need to get the code to be locally on the runner. And I'm going to walk through this, assuming someone hasn't used GitHub Actions before, just so I make sure I'm not missing anything. But the next thing I need to do, and if you're not familiar, these are all actions this uses. So Azure login is an action. Actions checkout is an action, and those are kind of pre-built things that you can use inside your workflows. I forget what Azure DevOps calls them. There might be plugins. I forget, or tasks or something. But anyway, I have to log into Azure, and so I have a secret that has my credentials, so I can authenticate to my particular subscription. And then I need to log into the ACR. So as part of this action, I get the Azure CLI installed on my runner. And runner is the term used to describe the node that this action is running on in GitHub's infrastructure. So I log into the registry. So that way I can use my Docker commands, because the Azure or AZ ACR shares credentials with Docker, the Docker CLI. And then I build and push it. So if we take a look, there should be container image. I think, is it on source? Where is it? It should tell me here. Build and push. Should be in the root of the directory. Oh, view all files. That's why I'm not seeing it. I have this Docker file. And so I'm building off a pretty old version of this Rust-based image here, and I'm using it as a builder. But more so what I am worried about is this. So this is a multi-stage Docker file. So I have one image that is responsible for building the Rust app, because that's going to require different software. And then I come down here, and then this is what it's actually going to run on. So I'm actually running on Debian Bullseye, this particular version. And that is an older version, because I wanted to make sure that there were some vulnerabilities that were discovered in the scan. And then it sets a working directory, and sets up some of the different things that the application needs. And then it exposes it here. So that's just the containerized version of the Azure voting app written in Rust. And then it runs that binary and creates the web server that you can connect to. So that's all that's doing, is it's building that container image. It's pushing it up into Azure Container Registry with this particular tag. So that environment tag is the version. I have the ACR name stored in an environment variable. And so it's up there. And the reason why I pushed it there is kind of a design decision that was made by Copacetic. So Copacetic can't currently patch local images. It looks for it on the registry. So there's a little bit of kind of a double work done, where the unpatched image is there, and then I push up the patched. But I usually override, that first version on that container image. But anyway, once the container image is there, I can scan it. Trivy has the ability to scan the images locally, but because I'm using Copacetic to patch, I'm just opting to scan the ACR one. Now, because I built it on the runner, Trivy will actually scan the local version of that, because it was built on the runner first and pushed up there, and the digest will match because nothing's changed. And so it'll scan locally and produce this patch.json. And that patch.json just contains all the vulnerabilities. I'm passing in some additional flags to say, hey, Copacetic can only worry about OS patches. So I'm only going to output to my report the vulnerability type of OS. And I also only care about critical. So with Trivy, you can also filter what vulnerabilities you care about. If they're, what are the different stages? There's high, critical, maybe low. There we go. So if you don't care about low and high, you can ignore them, really. So then this is a little bit out of date. This is actually this is all setting up the Copacetic binary, the executable, the CLI on the runner. There is an action available, and I'll show you that in the next workflow file here in a second. But I'm downloading it. It does require a build kit. So that's a Docker binary. And then I'm kind of running in the background, and then I'm patching. So here's the main thing though. So I run Copacetic patch, and then what I do is I'm overriding that existing container image. A typical practice we'll see in the next step is to append some kind of semantic versioning after it. So that way you can have identified that it's been patched. So you can have a non-patched version, and then you can see, oh, this image has been patched 1 time, 2 times, 3 times, etc. But in this case, I want to overwrite that first one because I want the patch version to be available. So this is just overriding on the container registry the unpatched tag of that particular Docker image or container image. And this is where I override it with this additional push. So this is just using Docker push. There's a lot of bash foolery that I'm doing here for those that aren't familiar. But all I'm really trying to do to get this command is I'm capturing the digest. And that's super important to use the digest of the container image. So every time that you modify a container image, you get output a new hash, a new SHA-256 hash value. And I need to use that to sign, because if I don't, like I said previously, I could just override the container image, and then I've lost all the integrity of that image. That provenance and the origin is gone because I no longer know where it came from. And so I'm using the digest. And this is important because you can overwrite it, but then the digest changes, and then Ratify will be like, hey, wait a minute, this is the same tag, different digest. So I'm going to reject this deployment. So that's why it's important there. And if you do signatures with notation or with Ratify, you'll get some warnings to say, hey, you probably shouldn't use a tag. You should use a digest. Which my first question when I started working with this tools was like, okay, well, what's a digest? I've been working with containers for probably 5 years, and I've never really cared or looked into what the digest actually was or meant. And so this is actually an action that I wrote and contributed to the Notary project, which is the setup action. And that just installs the notation on your CLI. And then here's the actual action to invoke it. And the reason why I wanted to show you this is because there's all these, it's easy to understand conceptually. Okay, I sign here and I, ratifies here, but there's a lot of steps. A lot of this is being worked on to be abstracted and built into different platforms, whether that be Azure or not. But if you want to start to use the open source versions of these, there's some things you got to learn. And it's like, here's a perfect example. Like what are the plugins? Well, I have my certificate, my signing certificate on Azure Key Vault. And so there's a plugin for that for notation to be able to install that plugin. So here's the path to that. And I'm using a checksum to make sure that that plugin hasn't been tampered with. And so that's how I verify that. But I also need to know the key ID. So what's the key ID of the signing certificate in Key Vault that I want to use to sign these container images? And then there's the target artifact reference, which is the fancy way of like, what is it you're trying to sign? And that's the full name, the subject name of that container image. But I'm using the digest in this, which I'm using that steps output digest to grab that. And that's some more fun trickery that you learn as you work with GitHub Actions. There's a signature format. There's 2 different formats. I forget the other one, but Coase is one. And then the plugin configuration. So I want to have self-sign be false. And then the plugin config also needs to know the name. What is the name of the certificate that you are trying to sign with, so that I can look it up in Key Vault. So what this all looks like, if we see it run, I think I have a successful build fairly recently when I was messing with the SBOMs. And I won't dive too much into it, but if we look at, probably, I want to make sure I can get the digest out of here. The build's pretty long. Dependency graph. Well, let's look at a different one, because I think yeah, it's a completely different workflow file. So I need to probably check out this one where I modified the Kubernetes version. And this is the right one. So that was a different workflow file that I mistakenly pulled up. But if we look at the notation, we should be able to see what it was called on right here. There it is. So here's the image with the SHA, or the digest rather. So that's another way that you can refer to container images. So if you want to do Docker poll instead of v1, you could look up what the digest is and make sure that you prefix it with this SHA colon here, and then put in that cryptic number, alphanumeric number, and that'll just be the digest that you can pull down. So that, yeah, that's probably enough of me rambling, but that's kind of the gist of what you would do. Again, all this is on this repository under my GitHub handle, Duffney's Secure Supply Chain on AKS. And this is something that I'm continuing to work on, so that it'll continue to evolve. But that's kind of like the high-level overview of how can I use all these open source tools to start to adopt some of these security practices when I'm deploying to AKS. Again, that's a very specific scenario. But yeah, gentlemen, have any questions?
I'm blown away by about your demo, but is there a specific reason why you is it just compatibility issues why you check out your code first and run it locally? Is it the only way that the software can handle it that way, or are there any other specific security reasons to do so?
Are you like when I run the action and I pull down the repository? Yeah. Oh, that's just so I can build it. So this is all part of my build pipeline. So the scenario to trigger this would be, right now the Azure voting app has a static code for cats and dogs, and I want to change that to be Go and Rust. And so that would be a change that would force me to rebuild my source code and recontainerize it and push it to ACR. So this is all inside the scope of that particular thing. So I need those files locally to be able to compile, and then to be able to containerize and produce some kind of build artifact that would be used later down the stream. From an operations perspective, the end result of this pipeline would be a signed and patched container image that then you're supposed to go and deploy to your cluster.
All right, thank you for that answer, because I was really triggered about the scanning being done on the locally checked out code, and actually
that's a fantastic point. I forgot to pull it out. Let me do you mind pulling up my screen real quick?
Yeah.
So this might resonate more with people. It's pretty uncommon that I've seen people patch on the left side of the pipeline where I'm doing it there. That's just part of adopting the more, I guess, a more secure approach to the software. But a more common use, in the original use case for Copacetic, if you look at this patch YAML, is, okay, I'm an operator, or I'm part of a dev team that's responsible for maintaining this registry, this ACR registry, or wherever it might be, wherever you're hosting artifacts. But I'm in charge of maintaining and operating this. And I have like this dev team. They created this image. Everybody's dependent on it now, and they moved off to something else, and they're not updating this image. It hasn't been updated in like 6 months. It's on a very old version of Alpine, what have you. So this workflow uses Copacetic to target. Let me zoom out a little bit so we can see more of it. But this uses the Copacetic GitHub action. And this is a more common scenario where I have a list of images, right? And so I only have one here that I'm worried about. But this is the unpatched version of the Azure voting app. Now imagine you had some process that went and scanned every image in your registry, and it was able to shove it in this images array, right? Or slice, depending on your nomenclature. And then I go, do the normal stuff. I log into Azure, log into container registry so the workflow can communicate with it. And this is just setting up BuildX on the runner, so that simulates that command that I was doing in my workflow. But then I have Trivy for every image in that array, or that matrix is the terminology that the GitHub workflow uses. I want to generate a report, right? So dev team 1 has 2 images, dev team 2 has 3 images, maybe even the ops team has some images that they host. I'm going to grab all those and I'm going to generate a report for that. So then I can use Trivy down here. So this is just checking to make sure that there are vulnerabilities to continue, otherwise it fails. And then this is this block here is generating a patch tag for each of the images. So what typically the pattern is to append, if you look at this tag here, just a -1 after that. So that way it's still semantically compliant, but it gives you some kind of an indication of how many times has this image been patched or has it been patched. You can literally just, all that little block down there is doing is adding a -1 at the end of this tag. But then it goes through and then uses Copacetic to patch them, right? So every image in my registry, I'm going to go and patch if there were any OS vulnerabilities found with Trivy. And then what I'll do is I'll push that patch tag up there with the -1 or -2, whatever it would be, and then it signs it. So that way there's a new version. So when I go to deploy on hopefully not Friday, I can go and look for, the latest patch version of this thing to update my Kubernetes manifest to pull down, or wherever that might be. Maybe you're using Flux CD and it automatically detects that there's a newer version on your registry. There's a branch in this repository to see how that works too. But yeah, so then you can just point this workflow at your repository, patch all the images, and then if you have something like GitOps set up, it just says, hey, there's a new version of this. I'm going to update my manifest and deploy the patch version of the image. So hopefully that gives more clarity from kind of the right side of the workflow and the left side of the workflow.
Yeah, absolutely. Because, well, knowing platform teams a little bit and handing out their infrastructure for developers to develop their application code into container environments, sometimes you have that fire and forget feeling. And looking at your code using a Debian 2021 version, I figured that it might come in handy to actually run a report similar like the one that you're just showing, to at least inform you about possible vulnerabilities, and the auto patching on those registry images. It's awesome. It's really helpful for keeping up on your security levels. So I was actually looking for an answer similar like this, but I didn't expect it to be that mature and automated already with actually patching your registry images. So I'm kind of eager to get my hands dirty on it myself, to be honest.
Oh, Copacetic's are really cool. That's probably the favorite one that I've worked on. Ratify, notation is necessary, but it's signatures, and there's, signatures are necessary, but it's one of those security things that's not like super dazzling. But the fact that I can automatically remediate, with automation, I can remediate OS vulnerabilities just in a workflow is fantastic. And the stars on that repository kind of show that. I think it went, it's pending CNCF adoption. I think it's an incubator right now, the Copacetic project. But it started at the beginning of this year with maybe 30 stars, and I think it's maybe hitting the 1K mark now. So it's gaining popularity because it solves a real problem, right? Like what you're saying, like this is super cool. I now don't have to go and badger people to update their base image. I can just patch and say, hey, use a different tag.
It's a Microsoft incubation, right? Or it came out of the Azure incubations team, or
it is by an upstream. So there's a container upstream team. I forget the gentleman's name, Sertok maybe, who is leading that project. But it is pending. They're trying to get it adopted by the CNCF. But yeah, it is Microsoft Dev.
Nice. I have a question. What's the point where you start rebuilding your image versus patching it with Copacetic, right? Are you just keep on patching it over and over again? Or at one point, like, okay, we patched it like 5 times. Now policy says, okay, we need to rebuild it, right?
That's a whole new fascinating area of like, how do you build secure images? So the patching really comes into play where I think it comes into play more where you don't have control over building that image. You're dependent on it. But if you control the image, then you have the ability to go and update your base image or to run apt update inside of your build process to generate a new one. And so that's where I see it, the division. Like if you have full control over the image and you can build it whenever, there should be some kind of a frequency of deployment that's helping you stay up to date with those patches. But if you're dependent on it and you don't have any say in when that image gets built, patching's your best option.
Yeah, fair enough. Fair enough.
If
And
they've made the image, I ran into this with Calio a while back, where they make it impossible for you to patch because they're using a distroless or a from scratch, where they blow away the file system. And then if you try to recover any of those the package binaries that hold all the metadata for the packages on the system, it's inaccurate. And then it throws off the scanner and says, oh, there's all these vulnerabilities that you don't really have, but there's no way to really patch that particular type of image. So that's another caveat I throw at you is it really depends on how your image is built, whether you can even patch it or not.
so, I can already imagine security asking about, oh, well, what's the status of, can you show me the report? And you're like, yeah, well, we're using this one, this one piece in our cluster that we do sign, but we cannot really scan it because they're using a distroless image.
Yep.
You're like, yeah, okay, but then you cannot use that. Yeah, but we don't really have an alternative.
It's not there, actually. Your scanner's off. Yeah, so that's a typical thing. I mean, it brings me back to my SRE days where, like something bad would happen, security get a bunch of money, and they'd just go buy like 5 different scanners, and then they generate a report and say, hey, here's everything wrong with the environment, and they'd send a ticket with 40 attachments to the ops team and say, fix it. And yeah, so a lot of these tools are aimed to help that particular scenario, but it's definitely the case because there's just different ways to build images, and if people don't understand that, it's just going to have to be a conversation for sure, because that's a whole new area, a whole nother area of like how do you secure these container images.
Interesting. So it starts with the best effort, like, hey, we're making this as secure as possible until, okay, we start enforcing things from an organizational policy perspective. Like, okay, we have these people actually babysitting our images and saying, okay, this is secure enough, this can run in production. But sometimes, especially with open source and all the tooling, and it still feels like a little bit of a duct taping exercise in terms of, okay, we have this, we have that, then you add Flux, then you add this, and eventually
well, they're all part of the pieces. I love all the Kubernetes memes. I don't know if you've seen them. Like what I'll try to find it so I can share it and you guys can put it on the screen. But one of them that I saw, my favorite one is it's Homer holding the Kubernetes icon, kind of like this, and he's walking up the stairway to heaven, and then the bridge, and then it falls into hell. But then all pops up like the bajillion of icons that are in the CNCF landscape, like Argo here and Flux here and all these other tools, which is the reality, right, of working in that ecosystem. But yeah, there's a couple other ones, but that's exactly to your point. Yeah,
interesting.
To it.
And the first time I heard about Copacetic was on your build session.
Oh, thanks for watching.
Yeah, of course, man. I saw it popping up. I'm like, oh, okay, I'm gonna sit for this one. It was really great, and I especially that's another topic. Impressed how you demoed it, right, with the tricks and the command line scripts and things like that.
Automated
So you did,
automated demos are the way to go, man. I tell you.
Yeah. So, but then I saw Copacetic, and I was like, no. Really? You go in there and you patch the container and then everybody goes crazy. Like, yeah, but they're supposed to be immutable. So how does that patching work? Does it layer another layer? It creates another container layer and then put it back? Or?
That's exactly right. It breaks open the container image. It basically appends a bunch of like app updates and injects in the things that were found in your vulnerabilities into a single layer. Like if you were to do a Docker, like a run instruction in your Docker file, it's essentially what it's doing and producing you another layer that is then added on top of your image. One thing that I want to plug quick, no ties or anything, but ChainGuard images, they have been doing phenomenal work in producing doing the hard work of making a secure container image. And so they take a lot of the guesswork out of like, how do I make this container image better? And so you can use them as your base layer. So they've been doing a lot of phenomenal work. Their blogs and articles are great for that particular layer. But yeah, just a shout out to them. I've been kind of peeking into that as I've been exploring. They've been super helpful on just breaking down the problem. And it's not super complicated work. It's complicated. It's a little bit of complexity to get your head wrapped around, okay, like what are the constraints and things that I need to be aware of to secure the image? But a lot of it's just the hard work of pulling the right base image, taking out stuff that you don't need, making sure stuff that's there is there, and then making sure that whatever you need, whatever dependency you have are up to date. And that's just the hard, continual grind that anybody that's worked in operations knows. You know, you got your updates you got to do, you got your new your version of your operating system you got to migrate to, and that's just the hard work that never goes away.
All these must-dos in operations. Yeah. So, Robin, Josh, I'm really impressed about what I've learned today about securing your supply chain in AKS. Like I said, I'm eager to get my hands dirty on it, and I will probably have some long conversations on the telephone with Robin as well about this topic, knowing him and speaking to him daily about these kind of topics. So we'll make sure that we will share the end results of that with you, Josh, so you can laugh about it or you can applaud about it, whatever it will be.
Yeah.
Let's wrap this episode up, because I don't think we can achieve much more learning out of it or much more enjoyment about it. And to be frank, I really want to get my hands dirty on it. So is there anything to add for you, Robin, for today's episode?
Oh, wow. Great episode. You know, Josh always is prepared. I've seen the repo before, but I'm definitely going to be following the docs and implementing it myself. I haven't got to it yet, but I'm eager to get started. Yeah, man. Great stuff, man. Thank you for
You bet.
you know,
One thing
teaching
that
us
I'll
new
throw out
things.
there is I have started a live stream series. So it's pretty much on like every Thursday. And you can find it on my X account or on LinkedIn. But it streams to the AKS community channel. And so I did a deep dive in containers, like breaking down what namespaces are. And I'll be diving into more of these tools from like an open source contributor perspective. So right now I'm working on Ratify and I'm trying to add in logging. But what you gain from that, at least what I gain from that, is a deeper understanding of how the tool is working. And so if you're interested in that, if you want to dive into these, it's titled The Code With Me. And that's really the intent is, hey, I'm trying to figure this out. I'm trying to learn this. The only difference is like I'm one DM away from whoever built it. And so I can ask those questions, but I want to share, my intent is to share all that learning that I go through with everybody out there. So if that's of interest, that's one thing that you might want to tune into. It's all recorded, so you don't have to do it live. Live just gives you the opportunity to ask questions or to see me struggle through things that feel really stupid. But yeah, that's the only other plug that I'll mention here. But super grateful to be on this show with you both, and yeah, thank you for having me.
Yeah, absolutely, and awesome to see the power of the community, right? So thank you for sharing that on the big bad interwebs as well. For our audience, make sure that you look up Josh Duffney on LinkedIn or X and follow his YouTube efforts. I really want to thank you as well for joining us today, Josh. I hope to invite you again sometime in the future for whatever evolutions there might be in the cloud native and containerization landscape. And yeah, well, let's wrap it up with this one. For all the people that are listening, we're back, season 2. Have now Robin Smorenburg as a co-host within the team. Make sure to follow us and stay tuned for some more epic episodes in the future.
Awesome. I'll vote for Golang, by the way.